So we have very few subjects here, as you can see, and we have three variables which gives values of each of the subjects, and you see the data set is quite small. We are into a problem of multivariate analysis. We have several variables, more than 2 variables, and very few subjects. But for different reasons, we want to expand our data set as the requirement of our analysis. We cannot do with such a small data set. So the issue here is how can we move from a small multivariate data set to a larger multivariate data set, the same variables but larger number of subjects. Remember that we should not disturb the interrelationship between the variables, because this is the concern of multivariate data analysis, that we have to study the variables along with their interrelationship and not in the variables individually. So we want to retain the relationship between them or interrelationship between them and generate a bigger data set. So that is the agenda today. Let us check it out how we can do using different types of statistical tools.
Well friends, so we have three variables here, as you can see, x, y and z, and each of them are having 5 values. So what we want is that use this data set to generate a more number of values for each of the variables x, y and z. So that the number of variables remains the same, but number of observations under each of the variables goes up as we wish. Maybe it goes up from 5 to 40 or 100 or 500 or even more. However, in this process, the structure of the variance covariance matrix of the variables and also the mean vector remains almost the same. So this is the what we want, and in order to do this, we are actually in R. We are presenting these commands in PowerPoint for better visibility, but these are run in the R. So we are actually assuming that we are in the R console. So we are providing below this presentation in the description and the entire code once again, so that you can just copy it and use it in R and check it out how it works. So we have now coming up the next command, and the next command is this is the next command, which here we are using a command cbind, which actually takes all the three variables x, y, z and puts them together. And O here, this is the covariance. This converts or calculates the variance covariance matrix of the three variables x, y, z for each of them having the 5 values as shown above. So we have this as the variance covariance matrix, which is the outcome of the previous command in R. Now, unfortunately, our R console does not accept this as the variance covariance matrix, or does not accept it as input for in matrix form. So this variance covariance matrix is to be converted into a matrix understandable in the R console. So for that, we first take all these values, and as you can see, we are taking the values row wise. That is, the first row we are writing, then the values of the second row, and then the values of the third row, and all of them we are saving in a variable which is called matrix underscore CO. We may give some other name of the variable, so it is up to you. Next, what we do is that we take convert this matrix into a 3-row 3-column matrix, as you can see here. So we convert the matrix, data matrix, that is the variance covariance matrix, or the values that we have written in the previous under the previous variable, into a 3-row and 3-column matrix, and we are taking the values 3 at a time for each row, and that's why we write by row equal to 2. So now this is a matrix which is understandable by the R console. So we have stored our variance covariance matrix in exactly a matrix form in this variable cb underscore mat. So you have to remember that this cb underscore mat, this is a matrix of variances and covariances, and next we also define the mean vector. So this is the command for computing the mean of the x variables, this is the mean of the y variable, and this is the mean of the z variables, and all of them are combined to another variable MNS. So these will go as inputs. This is the mean vector and this is the variance covariance matrix as you go to the next one. Now before we start generating a bigger sample from the data set having a given mean vector and a variance covariance matrix, we need to install a package which is called as MUS. While installing the package in R, we have to stay online and then follow the on-screen instructions, and we upload, we download a package called MUS. Once we do this, then next we run the library command, so that we call the library of MUS. So all the commands under this particular package are available. Following which, this is the main command which actually converts the mean vector as defined and stored in MNS and the variance covariance matrix which was stored in cv_mat of a sample of size 40. So this is mu stands for the mean vector which is given by MNS, and sigma, remember that this S should be capital and R is case sensitive. This is the sigma which is the variance covariance matrix, so that is where we are inputting cv_mat, the matrix we defined earlier, and a sample of size, and this is the command which is generating a multivariate random sample from a normal distribution with mean vector mu and variance covariance matrix cv_mat. So here MV stands for multivariate, R stands for random, norm stands for normal distribution. So this is R is random. So we are generating a random sample of size and storing it in sim data. So this is the place where we are storing the entire simulated random variables with the given mean vector and a given variance covariance matrix. In the next step, we may try to take it out in an Excel file in CSV format. So what we do is that we are writing this random sample in a CSV format. So first we convert the data into a data frame using this command. This we are giving the name df. You may give some other name as per your desire. So we have converted the simulated data under the three variables x1, x2 and x3, or xy, or rather xy and z in df. And then we are writing this df data frame in a particular file, CSV file, whose name is people, and then we are using this write command, write CSV command, and this will write or prepare a CSV file and will be stored in documents or my documents of your computer by default. If you want to place it somewhere else in some other folder, then you have to give the path name here. So accordingly it will be written in that particular folder where you want to save it, giving a particular file name which is people.csv. So that much was what we do. We are providing the detailed commands in the description for you to follow. Thanks for watching this video. Keep on watching Statisticians Hub. Please subscribe and share, and if you have some doubt, please place your comment. Also, if you want to have some deliberation on any topic of statistics as per your requirement, you may write it in the comment box. We will try to catch it up as early as possible. Thank you for watching.